scheduling algorithms. Hope you have understood. If you have any doubts, you can ping me later. Now the last algorithm or the last problem for solving for this lecturing will be round robin scheduling algorithm. In your round robin scheduling algorithm, here you need not have preemptive non-preemptive concept. In your round robin scheduling algorithm, you have process given here, you have burst time given here. Based on the process and your burst time, you are going to write the Gantt chart. But what you should remember here is important thing or important term called as time quantum. Time quantum is nothing but the number of milliseconds given for each and every process to execute in your CPU. Whatever is its burst time, the process will be executing only for this many quantum time. Later, next process should come into picture and it should execute. It cannot take complete its burst time and then come out. How is it? We will see. In order to write Gantt chart for this for this round robin algorithm, you need to keep in mind something called as ready queue. What is this ready queue? We will see. So first step is how to write the Gantt chart. When you start writing the Gantt chart, you know that process, when time is 0, arrival time is not given. So if arrival time is not given, we assume that all the processes arrives at 0th minute. So when all the processes comes at 0th minute, inside ready queue, all the processes have already come. So I'll be writing all the 3 processes inside my ready queue. That is P1, P2, P3. Now I shall see P1. Since it has come first, it will execute. What is the burst time for P1? It is 24 millisecond. But I have told we should consider or we should keep in mind the quantum time or time quantum given in the problem. So since the time quantum says that each and every process can execute only for 4 milliseconds, process P1 will also execute only for 4 millisecond. It will execute only for 4 millisecond. So here if I see process P1, 24 minus 4, 20 milliseconds. 24 minus 4 equal to 20 milliseconds is remaining. So again process P1 will be in ready queue. It will be added inside the ready queue because it has not completed its execution completely. Next process P2, if I check, process P2's burst time is 3 millisecond. If I repeat, if the burst time is less than the quantum time, it can complete and go away. You need not worry. Whenever the quantum time whenever the burst time is more than the quantum time, then we are going to add the processes inside the ready queue. I repeat, whenever the burst time is more than the given quantum time, you are going to insert your processes inside your ready queue. Now if I see process P2, the burst time is 3. So it will execute completely and go away. It will execute completely and go away. That is 4 plus 3 is 7. Next inside my ready queue, since it has completed, I am not adding here. If you observe, I am not adding it here. Next, I can see that process P3 is there in the queue. So process P3, I'll check the burst time, how much it is required. So that is also having only 3 milliseconds. So process P3 will also execute for next 10 milliseconds. It will also complete its execution and go away. Next, if I see, I have process P1 here. Process P1. So next 4 milliseconds it will execute. Next 4 milliseconds it is going to execute. So 10 plus 4 equal to 14 milliseconds. 14 milliseconds it will execute. So now again it has not completed its execution. I'll be adding it inside my ready queue. I'll be adding inside my ready queue. So now it will be 20 minus 4 equal to 16. Next, similarly again P1 I'll be adding. For next 4 millisecond it will execute. It will be 14 plus 4 equal to 18. Again it will be added into the ready queue. Again after adding it, it is remaining time will be 16. Next P1 up to 22 milliseconds. 18 plus 4 equal to 22 milliseconds. Next again I will be adding it into the ready queue, that is 8 milliseconds is remaining. So 22 plus 4 is 26. Then again remaining is 4. It will now complete its execution, 4 milliseconds. 26 plus 4 is 30. When the time is 30, the process P1 will be completing its execution. Why it is going to do it? Based on the quantum time given in the question. Now if you check here, the completion time of process P1 will be 30. Similarly for process P2 it will be 7. Process P3 it will be 10. Here also you need to add the waiting time. Calculate the waiting time, average waiting time, turnaround time and average turnaround time, and write all the values in terms of milliseconds. Please don't forget, write it in terms of milliseconds.